A flammable can be simply described as a substance which will readily catch fire and burn. Xylene, a commonly used flammable solvent, two identical amounts, sitting side by side in identical dishes. Now one does not ignite. The other does.
Flashpoint is the lowest temperature at which a substance gives off vapor that will burn. We must remember that it's the vapor that burns, not the substance itself.
In this program, we'll examine flammables and explosives, two classes which share a similarity: danger. Explosives are subject to very rapid chemical reaction or decomposition, releasing gas and heat with potentially violent results. Flammables and explosives, two classes to be careful with.
Gasoline is highly flammable. Its vapors ignite easily as far down as negative 45 degrees Fahrenheit. Yet even when this flash point is reached and a spark is created, the gasoline may not ignite. The reason is the gasoline's fuel-air mixture and limits of flammability. A chemical's lower flammable limit is the minimum percentage of vapor to air required for ignition to take place. There's also an upper flammable limit. If the percentage of vapor to air increases beyond this figure, ignition is no longer possible. The limits of flammability for diethyl ether, for instance, ranges from 1.9% to 36.5% by volume of air. Remember that most lower limits are reached very quickly, making it easy for a fire or explosion to erupt. Keep in mind that if there's enough vapor in the air to create a flammable atmosphere, the air will also be well above toxic limits. All flammables also possess what is called an ignition temperature. This is the minimum temperature required to cause self-contained combustion, regardless of the type of heat source involved. Carbon disulfide, for instance, has an ignition temperature of 80 degrees centigrade. Because of this, it can easily ignite through a nearby light bulb or steam line. Similarly, the surface temperature of a hot plate will ignite diethyl ether. Do your best to remove equipment that causes heat or sparks. Equipment such as stirrers and pumps can cause problems. Never use an open flame or a hot plate to heat flammables. Use instead a heating mantle or water bath. Consult your material safety data sheets for information on flash points, ignition temperatures, and flammability limits. Beware of static electricity. Make use of all static guard devices provided for you.
Adequate ventilation must be provided to keep chemical vapor in the air from reaching lower flammable limits.
Minimize all releases of vapor. Auxiliary ventilation is required when using some chemicals. Lab hoods help to confine and remove flammable and toxic vapors. Local ventilation control also helps prevent flashback, the accidental reverse flow of flame back to a container. Transport flammable materials in secondary containers. Rubber acid carriers are a good choice, as are plastic jacket overpacks. Carts should have large wheels to cross uneven surfaces. Do not use instrument, equipment, or mail carts. They are too easy to tip over or knock chemicals off of. Each chemical should have a definite storage place to return it to after each use. Avoid exposure to heat or direct sunlight. Flammable liquid should be stored in approved safety containers. Red with yellow tape identifies substances having low flash points. Arrestor spouts help prevent flashback. Remember proper container labeling. You don't want any confusion where flammables are concerned. Benchtop storage is undesirable. Containers are easy to knock over and unprotected from fire. In-hood storage is also unadvisable. Containers interfere with the airflow design and increase the number of chemicals that could be involved in a hood fire. We should store amounts greater than 1 liter in approved flammables cabinets. Cabinets need not be vented, but if they are, the vent pipe should have a flame arrestor. Keep the door closed and locked. Do not store flammables in a lab refrigerator unless the unit is approved as explosion-proof. The NFPA and your company's policies regulate how much flammable material can be stored within lab areas. It is very important that you consult your supervisor to determine safe storage levels. Securely strap flammable gas cylinders to benches or wall racks so they don't fall and knock valves open or break hose lines. Specialized training is required to work safely with compressed gases. Labeling is again important. Relying on the paint color of a cylinder is not enough. Many suppliers do not adhere to a strict color code. Do not mix flammable gases which may react with one another. Check all connections for leaks before using a cylinder. Use a diluted soap solution at fittings and valves. Check for bubbles. Create contingency plans for spill situations. Remember that flammable liquids spread quickly, and the larger the spill area, the greater the chance of fire. All ignition sources must be turned off. Keep cleanup equipment and materials nearby. Personal protective equipment is also important. See your supervisor about respirator training. Remember, vermiculate absorbents, such as kitty litter, do not keep vapors from rising dangerously in the air. Ask your supervisor about activated carbon absorbents, which may.
Some chemicals are affected by increases in temperature. They decompose quickly or become dangerously reactive. These are the explosives. Light, mechanical shock, and certain catalysts can also begin a reaction.
Some chemicals form an explosive compound when mixed, such as calcium carbide with water. Impurities in a sample can also be dangerous. Organic peroxides can form on containers of diethyl ether. Peroxides are notoriously unstable. They're highly flammable and far more susceptible to shock than even TNT. Something as simple as the friction generated by opening a contaminated can can cause an explosion. Check your material safety data sheets and other guides before you handle or store these substances. Know the problems which could surface. Use the smallest amounts possible to attain the desired reaction. Never involve yourself in unauthorized experimentation. If there's a potential for explosion, place your equipment behind a shield. Wear a face shield and appropriate gloves. A lab coat made from a slow-burning material is also necessary. Plastic is not recommended. Make frequent checks of stored containers. Look for evidence of corrosion or contamination. Push containers back from shelf edges.
Disposal of waste products can be tricky. Remember to take all the necessary precautions.
Ask your supervisor or safety officer about federal and local regulations. Your company has a complete plan on how to dispose of chemical waste. Very few materials can go safely down the drain. Water treatment plants cannot filter out all toxic substances. Flammables should be diluted so they do not pose a fire hazard. Simple reactions inside pipes can cause explosions. Waste containers for pickup should be properly labeled and placed in a separate area. You can also try recycling your chemicals. You must ask your supervisor if you have any questions, because you are ultimately responsible for making proper disposal arrangements. Plan ahead in case of fire emergency. Study evacuation maps and know your fire exits. In case of fire, evacuation may be your only course of action. Know the locations of fire extinguishers and emergency safety equipment. Only use them if you've been properly trained to do so. A self-contained breathing apparatus is dangerous when used improperly. You must be trained in order to use one.
Working safely with flammables and explosives takes a concentrated effort. They are dangerous. Take your time, learn the rules, and design your experiments carefully.